Okay, so let's take a look at some more examples of relations. So remember, I said a relation, that is a subset of a Cartesian product of, say, A cross B. But we also had the definition that a relation on a set A means that both elements in our ordered pair, so both entries in our ordered pair are going to come from the same set. So in this case, so we're going to let A be equal to the set 1, 2, 3. An example of relation on A would be something like this, where both entries in our ordered pair are coming from the set A. So this would be an example. So we say 2 is related to 1, 1 is related to 3, and 1 is related to 2. So that's how we could define a relation and what that looks like when you just have a single set that you're working with. So take a look at an example then. So if A is going to be the set of 1, 2, 3, 4, we'd like to find all of the elements of the relation R, where we're defining this as a set of all ordered pairs AB such that A divides B. So remember, when we look at sets, we have the set builder notation. We can think about that as the such that bar. So we're saying this describes some property that all of these elements are going to have. So if we're talking about the relation on this, we have to come up now with a set where we have a whole bunch of ordered pairs where the first number is going to divide the next number. And we're just looking at the set containing 1, 2, 3, 4. So how you can think about this is think about, okay, my first number here could be 1. Which of these numbers does 1 divide? Well, we should know that 1 divides 1. We should also know that 1 divides 2, 1 divides 3, and 1 divides 4. So these are elements that should be in this relation because 1 divides each of those. So then you move on to the next one and say, okay, well, number 2, which numbers does 2 divide? So does 2 divide 1? No. So in this case, 2 is not related to 1. Does 2 divide 2? Well, yes. So indeed, we have 2, 2 is going to be an element in this relation. Does 2 divide 3? No, but 2 divides 4. And then we ask the same thing about 3. Which of these does 3 divide? Well, the only one that 3 divides is 3. So 3 is related to 3. And then in this case, same thing with 4. The only one that 4 is related to is 4. So this is our relation. These are all the elements in this that are defined by this property defining our relation. So let's take a look at now some other constructed relations. And so again, we're looking at a relation on just a single set. So that means that both elements in our ordered pair, both these entries are coming from the set of all integers. So remember, Z is a set of all integers. So this relation is defined by the first one is less than or equal to the second. This one's defined by the first is larger than the second. And this one's saying that either these two numbers are equal or they're equal to its negative. So we can ask the question on which of these relations is 1, 1 an element of? Or in other words, which one of these is 1 related to 1? So we see, okay, is 1 related to 1 here? Well, yes, 1 is less than or equal to 1. So we know that indeed 1, 1 is an element of this. So you could either write this as saying 1 is related to 1 with this relation R1, or you could say 1, 1 is an element of R. And then we move on to the next one. Is 1 larger than 1? Well, no, but in this case, does 1 equal 1 or does 1 equal negative 1? Well, yes, it does. So we could also see that 1 is related to 1 using the relation R3, or you could also write this as saying that 1, 1 this should be R sub 1. This should be R sub 3. So in this case, 1, 1 is an element of R1, and 1, 1 is an element of R3, but 1, 1 is not an element of R2. Do the same thing for this one. Well, is 1 less than or equal to negative 2? Well, no. Is 1 larger than negative 2? Yes. So we could have 1, negative 2. This is an element of R2. Does 1 equal 2? Or does 1 equal negative, does 1 equal negative 2? Or does 1 equal negative negative 2? Or does 1 equal 2? Well, no. So this is the only relation that 1, negative 2 is an element of. So those are just some examples of getting to work with some specific examples of relations on a set and figuring out which one of these fall within certain relations and how do we just form the relation given some type of specific restrictions on the elements that are forming this.